All right, so the second thing we're going to look at here is dimensional analysis. And dimensional analysis is just a fancy word for checking to make sure that your dimensions match. That's what dimensional analysis literally means. But the idea here is as follows. If you are doing any type of mathematics, if your dimensions match, the math you are doing is possible and could be correct. If they don't match, whatever you're doing is wrong. Now, specifically speaking, there can be differences between units of measurement that share the same dimension, because those units of measurement can always be converted into the same units of measurement, so long as they share the same dimension. And dimension, again, and we're just talking about what physical thing they represent. So one question you might want to ask yourself is, if I am looking at a mathematical equation, such as addition, which is the most common way in which quantities are combined, is it possible for me to determine whether or not these operations are possible? So if you take a look at the one here on the top left, this is a mathematical operation in which you are asked to add 5 inches to 10 centimeters. Now, if you're going to ask yourself whether or not this is possible, I will tell you that it is possible. The reason that it's possible is because we're adding inches to centimeters, both of which have a dimension of length or distance. Even though they have different units of measure, they can be converted and added together because they're talking about the same thing. They're talking about how far you've gone. Now, you can do this in a variety of different ways. What you could do here is you could convert inches into centimeters. Right? If you do so, 5 inches is about 12.7 centimeters. And 12.7 centimeters can be added together with 10 centimeters to give you a single quantity. As long as your dimensions are the same, it is always possible to combine things together and get a correct answer using unit conversions. Now, if you look at the one over here that's on the right hand of the screen, we're going to try to add 5 inches to 25 seconds. If anybody writes this down, this is wrong. You can't add a unit of distance to a unit of time. Now, what's important to note is this also applies to units that have different exponents associated with their units of measure. For example, if you were trying to add 5 cubic centimeters to just 5 centimeters, you actually can't do this. These two quantities have different dimensions. This one here has dimensions of cubic length, or length to the power of 3. This one here has units of singular length. Even the exponents have to match for you to add things up. Length cubed, length times length times length, is a different dimension than just a single length. Now, not only can we talk about this with addition, we can also use this to identify different equations. So let's say that you have an equation here in which some quantity f is equal to m times a cubed. Right? It doesn't matter what these numbers are. What you can do is you can compare the units of each of these quantities to recognize whether or not this is true. So let's say that f here had a dimensions of distance divided by a time, which we'll use seconds for, squared. And let's say that here m has units of kilograms or mass. Right? So the square brackets here are just telling you that it is a dimension associated with this unit. And let's say that a here had dimensions of distance. Now, what you might ask yourself is, well, is this equation up at the top possible? And what you'll find is that it is not. And you can do so pretty quickly by inspection. If you take a look at this equation up at the top and you fill in your units, what you'll actually find is f has units or dimensions of distance divided by time squared. M has dimensions of kilograms, and a to the 3 has dimensions of distance to the 3, because again, exponents get applied to the dimensions as well. And what you'll notice is they ain't the same. If they're not the same, the equation is wrong. And that's pretty much all there is to it. This can be used very quickly to figure out if what you are doing is correct or incorrect. If you're provided with some random equations and you plug in your quantities and the units don't match up, it's wrong 100% of the time with no exceptions. So this is a powerful tool and technique because it means even if you have no idea, literally no idea what you're doing, you can at least tell if you're wrong if the units don't match up. This will help you do lots of things. If you're writing tests, it'll help you distinguish between different equations. Right? Say you have two equations, you're not sure which one is the correct one. Let me tell you, the one with the correct units is the one you want every single time.